Now we are going to start with a basic terminology of this chapter, that is an element. So what is an element? Element is a substance that can't be broken down into more simpler substances. As you all know that the element, the smallest substance what we study in a chemistry is an atom. You all know that, right? Atoms unite to form an element. But as we know that we cannot see atom, so obviously the substance which we can see, you can say that like from which the element is made, that is an element. So what is an element? Element is made up of atoms, and element is a substance which can't be broken into more simpler substance. Suppose if I give you some element and I ask you to just break it, so if you keep on breaking it more and more, and you know that even a smaller piece of an element will have the element only, because it cannot be broken into more simpler substance. So it is the simplest substance you can know that we can see with the naked eye. And you know that so many elements have already been discovered, and for that you all know that we have a periodic table where those elements have been placed. As we know that there are so many elements which have already been discovered, and there are so many discoveries are still lying in the pipeline. You know that like if we talk about the element are of two types. The basic main two types of an element is the metals and non-metals. Now you must be thinking that what is the difference between metals and non-metals? What are the properties actually which make an element behave as a metal, or what are those properties which you can say make an element behave like a non-metal? So we are going to distinguish among two, that is the metals and non-metals, depending upon the physical properties first. Right, so we are going to differentiate here depending upon the physical properties. As you all know that physical properties are something which you can see with your naked eye, or you can feel it by touching, right? So we are going to study about that what is the difference in the physical properties that lie between metals and non-metals. So the first thing is this, that metals are malleable. Metals are malleable, but non-metals are non-malleable. Now what do we mean by malleable? What do we mean by malleable? Malleable means, malleable is a property in which you can just beat the substance into thin sheets. So actually what happens is, in case of metals we say that they are malleable, that means they can be beaten into thin sheets. But non-metals are non-malleable, they cannot be beaten into thin sheets. Now the reason is that for beating them into thin sheets, you need to hammer them. And what actually, metals can actually bear a hammer, but the non-metals are brittle. Non-metals are brittle. They cannot tolerate the strain of hammer and they just break. So therefore, we cannot make sheets out of non-metals. Second difference is that metals are ductile. Ductile means, ductile is a property where a substance can be drawn into thin wires. So metals are ductile, that means they can be drawn into wires, but non-metals are non-ductile. They cannot be drawn into thin wire. Again the same reason for converting them into thin wires, we need to hammer them, and as I told you, they cannot bear the strain of hammer, so therefore they break. So due to this reason they cannot be drawn into thin wires. Third difference is that metals are good conductor of electricity, and we know that anything which is good conductor of electricity is a good conductor of heat as well. So metals are good conductor of heat and electricity, but non-metals are not good conductor of heat and electricity. The reason, as you all know, that for being a good conductor of electricity, there has to be a free mobile electrons. So free mobile electrons are there in metal, but they are not present in non-metals. That is the reason they are poor conductor of electricity, and we know that heat is an after effect of electricity. So obviously if they are not a good conductor of electricity, so they will be a poor conductor of heat as well, right? Next is that if we talk about metals, they are solid at room temperature. They are solid at room temperature, but if we talk about non-metals, they can exist, they are solid. We have few non-metals which exist as solid. We have a non-metal that exists as liquid, and we also have a non-metals which exist as gas at room temperature. But if we talk about metals, the most of them, I'm just not discussing the exceptions now, because after covering the physical properties, I'll just highlight the exceptional cases also. So as far as we are talking about the general properties, so we say that they are mostly solids, and they can be solid, liquid or gas. As they are solid, so obviously it is clear they are hard. They are hard in touch, and non-metals are generally soft. They are not so hard, but still I told you we have an exception, and we will be doing all the exceptions after covering these physical properties. So we are just talking about the general properties now. So they are hard and they are soft. Right, so as they are hard, so obviously their melting and boiling point is going to be high. So they have high melting and boiling point, and as they are soft, so obviously they will have a low melting and boiling point. One more property is that they are lustrous. Now what do you mean by lustrous? Lustrous is a property which make a substance shine. So any substance which shines can be said that it is lustrous. So what we have seen that metals are lustrous, but in contrast non-metals are non-lustrous. They don't shine. Likewise, the metals are sonorous. Sonorous means sonority or sonorous is a property that when any substance is hit with anything, it produces sound. So what we have seen that the metals are sonorous, that means when they are hit, they produce sound. But the non-metals are non-sonorous, as when hit, they do not produce any such kind of sound. So they are non-sonorous. They have high tensile strength. What is tensile strength? Tensile strength actually you can compare with that the force of attraction is quite high. They are you can say a rough and tough kind of substance. So they have high tensile strength, they can bear a lot of strain, but they have low tensile strength. Right. So these are the properties actually which you can list on the basis of physical properties between metals and non-metals. As I told you, we have an exception, so we are going to discuss the exceptions now. So as I told you that they are malleable, they are non-malleable, they are ductile, they are non-ductile, right? We don't have such kind of exceptions in this case, but still we can have a best malleable and best ductile metal, that is a silver metal. It is a best one. Next we have is good conductor of heat and electricity. So they are good conductor because they have free mobile electrons, but in contrast I told you non-metals are poor conductors. But here we have a exception, that is a carbon form. What form? That is a graphite. We know that graphite is a form of carbon. So though all the non-metals are poor conductor, but still the graphite is good conductor, and that is the reason it is used in making the electrodes of electrolytic cell. So graphite and allotrope of carbon is an exception here among non-metals, that it is a good conductor of electricity as well as heat. Next we discussed that metals are solid, but we have two metals which are liquid at room temperature, that is mercury and gallium. Mercury you all are familiar because that liquid is present in the thermometers which you use at home in order to indicate the fever, right? So those thermometers, they carry the liquid, that is a mercury, and you know that mercury is a metal, and you all know that it is a liquid, that is why it rises to a certain level on absorbing the heat. So mercury and gallium are the exception to this case, that among metals, all metals are solid but they are liquid at room temperature. And if we talk about the non-metals, we have many solid non-metals like carbon and many more, but liquid non-metal is only one, that is bromine. Bromine is the only non-metal that is liquid at room temperature, and gases are again so many: oxygen, hydrogen, nitrogen, these all exist as gases. But the liquid is only one, that is the bromine. Next, metals are generally hard, but you know that we have few metals which are so soft that even at home you can cut them with knife. What are those metals? They are sodium and potassium. Sodium and potassium are such metals which are so soft that they can be easily cut with knife. So this is an exception to metals. And as I told you, non-metals are generally soft, but again in this case also we have an exception, that is the exceptionally hardest substance, that is the diamond. You all know that diamond is actually a allotrope of carbon, so again it is a form of carbon, but it is the hardest known substance. So this is again an exception among non-metals, that it is hard in nature. They have high melting and boiling point. We know that the solids have high melting and boiling point, but in comparison the liquids, or you can say the soft metals, they have generally low melting and boiling point because the forces of attraction between them is not such strong. Like in this case, they have generally low melting and boiling point, but obviously the substance which will be harder is going to possess the higher melting and boiling point. They are lustrous, they are non-lustrous, but we have a substance among non-metal, that is a non-metal which is lustrous, that is an iodine. Iodine is actually lustrous in nature. So this is an exception to a non-metal, that is we have a lustrous, exceptionally lustrous non-metal, that is an iodine. They are sonorous, they are non-sonorous, they have high tensile strength, but the metals which are liquid or which are soft obviously is going to have a low tensile strength comparatively, and they possess the low tensile strength. So this is what is the difference between the metals and non-metals based on the physical properties. Now we are going to differentiate them on the basis of chemical properties. So I think you got it, that what is an element actually, and this metal and non-metal is the classification of the element only, and how you can differentiate among the metals and non-metals based on physical properties. So now we are going to start with the differentiation based on the chemical properties.